Welcome back friends. Welcome back to another video session from this channel. So in this video session we will be studying regarding the initiation phase of the transcription mechanism in case of eukaryotes under in vivo conditions. Is it clear? So though the transcription mechanism in case of eukaryotes under in vitro conditions, though it is very similar to the initiation phase of the transcription mechanism under in vivo conditions, but still the initiation phase of the transcription mechanism under in vivo conditions, it takes the advantage of certain modifying enzymes and certain mediators, because as I have already mentioned you earlier, the specific DNA which acts as a template for organizing the transcription mechanism, it is available in a free form under in vitro conditions, but whereas under in vivo conditions, the specific DNA which acts as a template for organizing the transcription mechanism, it is not available in a free form. The specific DNA, it successfully wraps around the histone octamer. So once when the specific DNA, when it wraps around the histone octamer, it leads to the formation of nucleosome. After the successful formation of nucleosome, then after the specific DNA, it successfully packs into the chromosome. So the reason why, in order to unwrap the DNA around the histone octamer and in order to induce the chromatin loosening, the specific transcription mechanism or the specific initiation phase of the transcription mechanism under in vivo conditions, it takes the advantage of certain modifying enzymes and certain mediators. Is it clear? So let me write it on the board. So what are the various mediators here? RNA polymerase 2 in association with GTF, that means general transcription factors, and as well as mediator complex, and in addition histone acetyl transferase. And in addition, nucleosome modifying enzymes. So all these are the various components, or all these are the various elements which are required for organizing the transcription mechanism in case of eukaryotes under in vivo conditions. So for your better understanding, let me present it on the board. Is it clear? So let us assume it has the genomic sequence, right? Double stranded genomic sequence. Double stranded genomic sequence. So here it is nothing but the upstream activating sequences. Upstream activating sequences. Upstream activating sequences. And here it is nothing but the promoter proximal element. Promoter proximal element. Is it okay for you? So here it is nothing but the activator, the positive regulator. And here it is nothing but the promoter region. Promoter element. So here, as I've already mentioned you earlier, under in vitro conditions, the specific RNA polymerase II, by taking the advantage of general transcription factors, it successfully recruits to the promoter region. But whereas under in vivo conditions, the specific RNA polymerase II, it is unable to recruit to the promoter region so accurately because the specific DNA, when it wraps around the histone octamer, under such condition, the specific RNA polymerase II, it is unable to recognize the promoter region. So in order to overcome the problem, in order to eradicate the problem, the transcription mechanism under in vivo conditions, it takes the advantage of a specific enzyme, and it is nothing but what? Chromatin modifying enzymes. So in the presence of chromatin modifying enzyme, the specific chromatin, it becomes loosening. So once when the specific chromatin, when it becomes loosening under such condition, the RNA polymerase enzyme, it is capable to recognize the promoter region. And in addition to the specific chromatin modifying enzymes, the RNA polymerase II, it takes the advantage of a specific complex, and that specific complex, it is nothing but what? Mediator complex. The specific RNA polymerase II, which is in association with the general transcription factor, it not only takes the advantage of chromatin modifying enzymes, and in addition to the chromatin modifying enzymes, the transcription mechanism in case of eukaryotes under in vivo conditions, it takes the advantage of mediator complex. So in the presence of mediator complex, the RNA polymerase II, it is capable to recognize the promoter region so accurately. Is it clear? So let me present it on the board. So here it is nothing but the RNA polymerase enzyme. RNA polymerase II. And here it is nothing but the mediator complex. Mediator complex. Mediator complex, and here it is nothing but the chromatin remodeler, and here it is nothing but the histone acetyltransferase, simply termed as HAT, and it is nothing but the chromatin remodeler. Chromatin remodeler. So here the RNA polymerase II, which has recruited to the promoter region, it is in association with various general transcription factors. So all these are the various general transcription factors. So in the presence of general transcription factors, the RNA polymerase II, it is capable to recognize the promoter region. So here once when the specific RNA polymerase II, when it successfully recruits to the promoter region by taking the advantage of chromatin modifying enzymes and the mediator complex, under such condition, the RNA polymerase II, it is capable to incorporate the RNTP so accurately. Here the mediator complex, it not only it is responsible for the successful recruitment of the RNA polymerase II to the promoter region, and in addition, the specific mediator complex, as the name itself suggests, it acts like a mediator in between the RNA polymerase II, which is in association with the promoter region, and in addition, it acts like a mediator in between the positive regulator, which is in association with the promoter proximal element. Is it clear? So if we consider the composition of the mediator complex, the specific mediator complex, it is composed of around 20 subunits. Is it clear? So let me write it on the board. Mediator complex. Mediator complex, it is composed of 20 subunits. So here the specific mediator complex, which is composed of 20 subunits. So here the composition of the specific mediator complex, it remains vary from one particular organism to the another organism, or from one particular species to the another species. So in all the living organisms, the composition of the specific mediator complex, it won't remain similar. It remains vary from one particular organism to the another organism. So here the mediator complex, it is not only responsible for holding up of the specific RNA polymerase 2 to the promoter region and as well as the positive regulator, and in addition the specific mediator complex, it acts like a platform for the successful binding of the alpha C-terminal domain. Is it clear? So let me write it on the board. So what it is? Alpha C-terminal domain. Alpha C-terminal domain. So here, as I have already mentioned you earlier, the specific alpha C-terminal domain, it possesses or it consists of an haploid repeat sequence. To the haploid repeat sequence, the specific general transcription factor, which is nothing but TF2H, it comes into the picture. As I have already mentioned you earlier, the specific TF2H, it possesses a kinase domain. So here the specific TF2H, it successfully binds to the haploid repeat sequence, so that once when the specific haploid repeat sequence, when it is in association with the TF2H factor, under such condition, the closed complex, it successfully converts into open complex, and even the RNA polymerase 2, it is capable to incorporate the RNTP so accurately. So this is regarding the initiation phase of the transcription mechanism in case of eukaryotes under in vivo conditions. So I hope that this video will help you a lot. So if you like this video, just hit the like button and share it to your friends. And I remember you people to subscribe my channel for getting more and more videos what I make day to day. Thank you.